Hi everybody, this is Mrs. Slauson, one of the Algebra 2 teachers, and I am going over learning target number 6, graphing log functions first attempt. So for the first graph, I will be making two tables. The first table will be using the idea that a log graphed function comes from an exponential graphed function, and that if you know how to graph an exponential function, then you can essentially graph a log function. Then when I proceed and finish the other ones, I will only be making the one table. So the idea is, just starting in general, is, what is that exponential function I would be using? And I have my students circle it. We would be looking at 2 to the x. And so from there, we would be making our table for an exponential function, and we would put our x values here, and then we would just start putting our exponent in. So what you could do is a couple of different things. Is you could think of this as 1 times 2 to the x power, which is what happened in the exponential graphing ICAM, and then that you would be beginning with 1. That's what this says, like a y-intercept, and then that you would continue to multiply by 2. So 1 times 2 is 2, 2 times 2 is 4, and I just work this way up by multiplying by 2, which means this way I would be dividing by 2. So that just turns it into 1/2 and 1/4. Now the other way to think about it, if you don't want to use the 1 times the 2 to the x, I'm going to do a little erasing here, is again, I would think of this as my table of my x and y's, and I'm going to use 2 to the x power to make y. And that if you start with 0, anything to a 0 power, 2 to the 0 power is 1, 2 to the first power is 2, so I'm just putting these numbers in here for this exponent. 2 to the second power is 4, and then when you have the negative exponents of these, then it just takes your answers and moves them. So if 2 to the first is 2, then 2 to the negative first is 1/2, and then 2 to the negative second would be 1/4. So once you get your exponential table, what you can do from there is make your log table. And so logs are the exact opposite of graphing exponentials. So over here in orange, this is what I would then use for my exponential. The x's would become the y's, and the y's would become the x's. So I'm just going to basically swap the columns around. And then go from there. So what I don't need anymore is this column or this table that I have in green. So let's talk about the log function itself. So besides the log base 2 with the x, there's a 3 and a -4 that have jobs. And so we're going to start with the 3. With the 3, you always do the opposite, and then that would tell you to go all of these points and the wall. The asymptote will go left 3, and then they will also move down 4. In a log function, we now have a vertical wall, which typically starts right here where x equals 0. This wall is now going to be affected by moving left 3. So I'm going to erase this and just move it left 3. And I'm going to put it right here, and I'm going to name this wall. I'm going to call it x equals -3, because every point on that wall has an x value of -3. And then I'm going to go to my points now. I'm going to stay away from the fractions, and I'm going to graph my points. Now, since we aren't going to get a lot of points on here, it will be helpful to know your shapes. So what we did in my Algebra 2 class is we made a little table after graphing enough of them, and we said that if your shape represents growth, it's going to look like a lowercase r, like there is in growth. If it's decay, then it's going to look like decay from the last chapter in exponentials. Now, if it flips, when something flips, we're flipping over the x-axis. So if you want to take a moment and think of this line as the x-axis, and then, although you can't see it, what I would do is turn my phone screen around, and I'm just going to draw the growth shape mirror image. And then I'm going to draw the decay shape a mirror image. So if you turn your phone around so that this blue line, that again, that I'm kind of redrawing really well, is going up and down, you can see this mirror image probably a little bit better. So in black is growth and decay, and in blue what will happen is if these are flipped or a reflection. So let's go back to graphing our points. So I'm going to start with my 4, 2. So I'm at 4, 2, and although you maybe can see that little cursor there, it's not going to stay there. It's going to go left 3. So I'm going to count over 3. So 4, 2, and we go 1, 2, 3, and then I'm going to go down 4. 1, 2, 3, 4, and I'm going to end up right there. And I'm going to just do that for all the points. So I'm at 2, 1. I'm going to count left 3, down 2, or down 4. And I'm going to go to 1, 0, and move it left 3 and down 4. 1, 2, 3, 4. And now that I got my points, since I was technically multiplying by 2, this 2 right here over and over again, when you multiply by 2, your shape gets bigger. So since it's growth and it's not flipped, I'm just going to draw that lowercase r in there, and it's going to look like this. So now what it's time to do is put in our arrows, like the infinities and stuff. So we're going to start with the right arrow, nothing's stopping it, so it's going to the right, which is infinity, and then it's going up, which is also infinity. Now when I go for the other arrow, this arrow is being stopped by the wall. The nice thing is when I do name this x and y coordinate, I actually know what the x value is going to be. It's the wall value, or the vertical asymptote, -3, and then it's going down, so my y value will be -infinity. And now when it's time for my domain, although I wrote in that space, the domain is going to be -3 to infinity. And the range is going to be all real numbers, this funky r, or you could do the infinities if you want, but just don't forget your parentheses. All right, and then the transformations I did indicate with that L3 and that down 4. All right, let's go to number 2. So at this point, I'm only going to be making one table. And I'm just going to realize that when I make my table, that the -2, -1, 0, 1, 2 that was on the left side will just be moving to the right side. And notice I'm not filling in x and y at the top of my table. I think that might get a little confusing. So let's go ahead and get the table filled out, and that's what this 1/3 to the x power is going to help me do. So I'll be taking 1/3 to an exponent, and those exponents are the -2, -1, 0, 1, 2. So let's start with our simplest one. Anything to a 0 power, including 1/3, is going to be 1. If I take 1/3 to the first power, then I'm at 1/3, and 1/3 to the second power, well, that's just 1/3 times 1/3, that gives me 1/9. Now, when I get their negative exponents, what's going to happen is that the fraction 1/3, everything moves. The 1 moves to the bottom, the 3 moves to the top, so it just becomes 3, and then this one becomes 9. All right, let's talk about the other numbers that are on here. So this -2, I will be using the opposite, and that is going to tell me to go right 2. I'll put it down here, the transformations, and the 1 will say up 1. So what will be affected with my vertical asymptote is the right 2. So it's going to end up right here, and I'm going to name that wall as x equals 2. And now I'm going to go to my points, and I'm going to find 9, -2, which doesn't quite fit on the graph, but that's okay. I can still handle that. I can estimate where I think it might be. So I'm at 9, -2. I'm going to put like a little dot of where that is since there's not a grid paper. And now I'm going to move that right 2, which is still not on the grid paper, but that's okay. But once I move it right 2 and up 1, it's going to be right there when I'm putting this little, well, it's supposed to look like an X. Okay. And then 3, -1. So I'm at 3, -1, and I'm going to move it right 2 and up 1. It's up right there. And then I'm going to take 1, 0 and move it right 2 and up 1. Oh, I lost where I was. So 1, 0, right 2, up 1. And now I want to think about the shape. So if technically in an exponential function, I'm always multiplying by 1/3, my shape should be, or my value should be going down. So my graph should be looking like this as decay. And it's not flipped, so it's going to stay that way. So that's just how I'm going to graph this. All right, let's take care of those arrows with the infinities. So starting with the right arrow that is not getting stopped, I'm going to have to the right is infinity, going down is actually -infinity. And then the arrow on the left that's getting stopped on the wall, the nice part about that is I do know the x value. It's going to be the wall value of 2, and it's going up, so I have infinity. So this time they want my end behaviors. So the end behaviors, there's not that much room. I'm going to squeeze one of them in here. So as normal, I write that LIM for limit notation. As x is getting bigger, I would want to know what the y's are doing or what f of x is doing. And so I'm going to look right here because this is where I had x is infinity. And so that means the y's are going down to negative infinity. Now, when I do the other one, typically after the LIM, we have x with negative infinity, but in our arrows, we didn't have x as negative infinity, so we had it from 2, and if your teacher talked about that, this little plus sign, if you do it, that's great. If you don't do it, that's okay too. It just means we're coming from the right side, from the positive side. But then, what are the y's doing? So if x gets closer and closer to 2, what are my y's doing? And they are getting bigger infinity. All right, let's move to the next one. So 3 seems like it's missing something. It's missing its base. So what I'm going to do is write it's understood invisible 10. And now I'm going to make my table. Again, I will be putting my -2, -1, 0 in on the right side instead. And I will be using this 10 to the x power to help get the other points. So again, anything including 10 to a 0 power is 1. 10 to the first is 10. 10 to the second power is 100, which will never fit on our graph. And then their negative exponents just moves the 10 into a denominator and the 100 into a denominator. And the only 2 points I think I'm going to possibly be able to get on there are going to be these 2. So let's start with our wall. The other number, this, I think can't quite see, this other number, this -3 means everything is going to go down 3. And so that means my vertical asymptote at x equals 0 is actually not going to be affected. So I'm going to find 1, 0, and I'm just going to move it down 3. And I'm going to estimate where I think 10, 1 is and just move it down 3, so maybe about here. And then since I only have 2 points, I do need to think about that shape. So if in an exponential function, I'm always multiplying by 10, my value should be getting bigger, so this should be growth. So think of this R as the R in growth. So I'm going to go ahead and connect my points. I'm going to fill in my arrows. So the right arrow, again, is not getting stopped, so it's going right and up, so infinity, infinity. And then the other arrow, I know the x value, it's my wall. It's telling me that x should be 0 and negative infinity, because the y's are going down. And so for my range, if you still have yet to figure this out, it's always all real numbers. And then your domain is going to be your wall value with infinity. And the final one, probably maybe the tougher one because we finally have a stretch. So let's deal with that real quick. So that 2, that is a stretch of 2. And this 3, that is that my points are going to go left 3. So now when I make my table, again, I'm just going to make one table. I'm going to put my -2, -1, 0, 1, 2 on the right side. What I'll be using to make the table is this 3 to the x power. So anything to a 0 power is 1, 3 to the first is 3, 3 to the second is 9, and then those negative exponents just move the 3 and the 9, whoops, as I said 3, I wrote it, into the denominator. Now, because I do have a stretch, I need to take all the y values and multiply all these y values by 2. So this 2 that I keep writing in parentheses, that is my stretch. So now I have a new y value of -4, -2, 0, 2, and 4. And because that's so many numbers, I like to just cross off the old y values so I can just focus on the x and the new y values. So let's go ahead and deal with this wall. Right now it is here, but because of that left 3, that wall is about to move and it's going to end up right here. And we can name this wall x equals -3. And I'm going to take my points. I'm not going to use the fraction ones. I'm just going to graph the integer ones, the ones without the fractions. So I'm at 1, 0. Whoops, and I erased my 3 here. And it's going to go left 3, up right there. I'm at 3, 2 right now, and it's going to go left 3. And then 9, 4, which just barely fits on the graph. That's okay. We'll go left 3 and end up right here. And now when I think about the shape, because we're always multiplying by 3, my shape should be growing. So there is an R for growth. So here comes my R for growth. And then this arrow is infinity, infinity, because it's going right and up. And this arrow is going to hit the wall, so my x value is -3, and it's going down for negative infinity. And on this one, we did not ask you for any domain or range or end behavior. So just a couple things to notice. The range in every problem is always all real numbers. And the other thing to notice, if you haven't noticed, is that your log function is always on the right side of that asymptote. It's never on the left side and never crosses the left side. So just some things to think about when you do take your second attempt. And that's it.